We are going to be looking at problem number 3, or exercise number 3. This is from chapter 3, section 4. We're looking at modeling of quadratic functions here. And in this particular problem, they asked us to find the quadratic function that models the data below. One of the things I wanted to do before I got into using the calculator is to... I'm getting my pointer set up here. Give me just a second. And see if I can get my screen. Oh, let's use blue because that's what's here. What I want to do is look at something that is called the second difference. If you look at your screen here, you can see that for my x values, the difference between any succeeding x's is always going to be 1. -2 plus 1 is 1, -1 plus 1 is 0, and so forth. These are all straight in a row, and so that's one of the things that we need to note first. In another lesson, when we were looking at linear models, we looked at just the first difference, but now we're going to look at what's called the second difference. If I look at the difference between the 16 and the 5, 5 minus 16 will give me -11. If I look at the difference here between 5 and 0, 0 minus 5 is going to be -5. If I look at this difference here, 0 minus 1 is going to be negative. Oops, I have to do it the other way. That's going to be a +1. Then 8 minus 1 is going to be 7. And if I look at this difference here, 21 minus 8 is going to be equal to, and this will be about the last one of these I do, 21 minus 8, my brain went numb here. I guess that's going to be 13. Let me just do one more. You can see the pattern here. 40 minus 21 is going to be 19. Now what we can do, this here is called the first difference. So this one is the first difference. Now if I want to look at the second difference, what we can do is take the differences between these. So if I take -5 minus a -11, that's going to give me a +6. 1 minus a -5 is the same thing as 1 plus 5. That gives me 6 again. If I take 7 minus 1, I get 6 again. If I have 13 minus 7, I get an answer of 6. And then finally, for what I'm doing, 19 minus 13 is going to be 6 again. So we see that our second difference is a constant. And if I had completed the other ones, you would see the same thing. But this is a constant, so this tells us that this fits a quadratic model exactly. So this is going to be a quadratic. If I can spell, and it's going to fit exactly. Now, to find out what this model is, we're going to go use our calculator, and we're going to input this data into the calculator. So first of all, we can turn it on, and I'm going to go to the Stat menu, and since I don't know what's here, I'm going to clear out a couple of lists, and so we're going to clear some lists. Let's just clear list 1 and 2. So I hit second L1, comma, second L2, and if I hit enter, that's going to clear out anything that may have been there before. Now we go back to the Stat menu and we're going to edit. And I'm going to scroll over here to list 1 and I'm going to put in my data here. So under the L1 column, I'll put my x's, so that's going to be -2, enter, -1, enter, 0, enter, 1, enter, 2, enter, 3, 4. Hopefully I haven't made any mistakes. 5, 6, 7, and we had an 8. Okay. For the next one, if I scroll over to the L2, my first one was 16. My next one was 5, 0. This goes through the origin. 1, 8, 21, and 40. And 65, this thing gets pretty big now, 96, and 133, and the last one we had was 176. And so this is my data. To come up with a model that we are asked to find, we are going to now go back into the Stat menu, and we're going to go to Calculate. We have determined that this is going to be a quadratic model, so I'm going to go to number 5 here for quadratic. And I'm going to tell it where my x values are. They're in L1. I'm going to tell it where my y values are. They're in L2. And I'll hit enter. And this gives us our model. I was expecting to see one other thing on the screen that I don't see, but this is an exact model. If we translate what this means here, if I write down my answer, translating this, we're going to have y is equal to, we have a, which is in our case 3 times the x squared, and then we have minus 2, which is the b, times the x, and our constant c is 0. This then completes exercise number 3 from section 3.4.